Hello everyone, my name is Shantamusen Mutsinzi. I'm from Soko Campus, School of Agriculture and Food Science. Our department is Agriculture, Economics and Agribusiness. We have in year 1 and we have been given an assignment of climatology to discuss about solar radiation. So we are here as group, we are 5. Then we are going to discuss and dive deep through you for what we have been discussing. So we would like to catch up some of your attention to give you what we have been discussing all these times. So I hope we are getting along together. Thank you. Those are the group members. We are 5. We are going to show you, we are going to discuss the topic you have given in deep. So we would like to be with you sometime, a little time. The topic to discuss is called solar radiation. Solar radiation, it is chapter 3 in the course of climatology, and we are going to discuss about it. So let's start the solar radiations, and we discuss it in deep. Content, these are the contents that we are going to follow in this presentation. So the first, we are going to make introduction and concept used in solar radiations. So the different component of solar radiations will follow. The next, we are going to discuss about the source of solar radiations on the Earth. Here we will see where the solar radiations come from. Then after, we will see the instrument used to measure solar radiations. As we see, solar radiation must be measured using different instruments. The next is the factors that influence the amount of solar radiations that reaches on the Earth. The impact of solar radiations on the Earth, we are going to dive deep in it. Applications and challenges of solar radiations that we are going to see in this presentation. Okay. After discussing applications and challenges of solar radiation, we are going to see the conclusion, and then our presentation will be done. Then this is an interactive assessment. It consists of questions that an audience, you who is watching this video, you first have to ask yourself and then find some answers and talk about how you understand it. So the question number 1 is asking about what do you think is solar radiation? So in your own words, before you say anything, what do you think is a solar radiation? The second is, where do you think does the solar radiations came from? This is your question, this is your task. Just first answer yourself. Where do you think can solar radiation be derived from? The second is, what are the main components of the solar radiation? So we will see in the presentation, but before we discuss it, just ask yourself what can be the main components of the solar radiations. The fourth question states that give at least the 3 factors that may lead to the difference of solar radiations in the different regions. So the fifth question is explain how the solar radiation may be useful. You need to see or to mention the usefulness of the solar radiations on the, for example, in the life of a human or other biotic factors. So after those interactive assessment questions, and we are going to start the presentation. So I would like to invite my colleague Umwari to continue and explain you about the solar radiation. Thank you.
Hello, my name is Faithy. I'm going to tell you about introduction of solar radiation. Solar radiation refers to the electromagnetic energy emitted by the sun and reaching the earth. It is a key driver of various natural processes on our planet and is essential for supporting life and empowering many renewable energy technology. Let's continue to concept used in a solar radiation. The first one is radiation. The emission of energy as electromagnetic waves or as moving subatic particle, especially high energy particle which cause ionization. The second one is light, the natural agent that stimulates sight and makes things visible. Light is the prominent component of solar radiation, representing the visible portion of the electromagnetic spectrum. The third one is wavelength. Wavelength is solar radiation lived to the distance between peaks or varies of wave in the sunlight. It helps us to understand the size of wave that makes up the sunlight. Different types of waves like ultraviolet, visible light, and infrared have different size or wavelengths. The fourth one is absorbance is the function of solar radiation absorbed by the surface. Let me continue to the component of solar radiation on the next slide. Oh, sorry, I made the mistake. The next slide is different types of wavelength. The first one is radio, the second one is far infrared, the third one is near infrared, the fourth one is visible light, the fifth one is near ultraviolet. The next is far ultraviolet. The next one is X-rays. The last one is gamma rays. Let me continue to the component of solar radiation on the next slide. Here there is the component of solar radiation. The first one is ultraviolet radiation. In other words, is UV radiation. UV radiation is types of energy that comes from the sun. It has shorter wavelength than visible light, which means the waves are closer together. It plays a role in production of vitamin D in our body. However, excessive exposure to UV radiation can be harmful and increase the risks of skin cancer. The second component of solar radiation is visible light. Visible light is a part of solar radiation that our eyes can be detected. It consists of different colors that we see in rainbow, such as red, orange, yellow, blue, and violet. Each color corresponds to a specific range of wavelength. Visible light is essential for our vision and allows us perceive the world around us. The last one is infrared radiation. Infrared radiation is a type of energy that is felt as heat. It has longer wavelength than visible light, which means the waves are more spread out. Infrared radiation is divided into three categories. The first one is near, the second one is mid infrared, The last one is far infrared. Infrared radiation is responsible for warmth you feel when standing in the sunlight or a fire. It's used in various applications, including thermal imaging, remote control, and heat therapy. Let me invite Marie Canesa to continue about subtopic.
Hello, my name is Marie Canesa. I'm going to introduce about source of solar radiation on the Earth. The primary source of solar radiation on the Earth is the sun. The sun is emit vast amount of electromagnetic energy across a broad spectrum, including ultraviolet, visible light, and infrared radiation. This energy radiates outward in all directions, and a portion of it reaches the Earth's atmosphere and the surface. This is a picture of a source of solar radiation on the Earth. As you see, we have a reflections, absorption, and the income solar radiation. The first is the reflection. Some of the income radiation is reflected by Earth's surface and the atmosphere back out to the space. The second is the aberrations. Most radiation is absorbed by the Earth's surface and warm it. Some heat pass out into space. Most heat is absorbed and re-emitted by greenhouse gas molecule, further warming Earth. After see the source of solar radiation on the Earth, we have instruments used to measure solar radiation. The first one is pyranometer. Pyranometer is a device used to measure the total solar radiation received on the horizontal surface. It's measure both direct and diffuse solar radiation. The second instrument is the spectroradiometer. Spectroradiometer is instrument used to measure the spectral distribution of solar radiation. It measures the intensity of solar radiation across different wavelengths or colors, including the distribution of ultraviolet, visible, and infrared radiation. The third one is pyrogeometer. A pyrogeometer is used to measure long-wave infrared radiation, also known as thermal radiation. It measures the downward and upward long-wave radiation emitted by Earth's surface and the atmosphere. Thank you for your attention. This is my end of my explanation. Let's invite other members, Sandrine, to continue with factor influencing the solar radiation on the Earth's surface.
Hello, my name is Tisek Sandrine. I'm going to continue with the factor that influence amount of solar radiation on the Earth. The first one is atmospheric conditions. The Earth's atmosphere plays a crucial role in the distribution of solar radiation. When solar radiation enters the atmosphere, it undergoes various interactions, including scattering, absorption, and reflection. The second one is latitude. Solar radiation varies with latitude due to the curvature of the Earth. Near the equator, solar radiation is more direct and intense throughout the year. As you move toward the poles, the sunlight is spread over a large surface area, resulting in lower solar radiation intensity. The third one is seasonal variation. The tilt of the Earth's axis causes seasonal variations in solar radiation. During summer in one hemisphere, that hemisphere is tilted toward the sun, resulting in more direct sunlight and higher solar radiation intensity. In winter, the same hemisphere is tilted away from the sun, leading to less direct sunlight and lower solar radiation intensity. Next one is altitude. Solar radiation intensity changes with altitude. Higher altitudes receive more solar radiation due to reduced atmospheric attenuation. Next one is cloud cover. Clouds can reflect, absorb, and scatter solar radiation, reducing the amount that reaches the surface. The type and thickness of cloud, as well as their coverage, impact the amount of solar radiation reaching the Earth. Let's continue with the impact of solar radiation on the Earth. Change in solar radiation pattern can disrupt ecological processes, including migration patterns, reproductive cycle, and food availability of various species. While solar radiation itself is not a direct driver of climate change, variation in solar activity can influence long-term climate pattern over a geological timescale. We have the positive impact and the negative impact of solar radiation on the Earth. Let's proceed with the positive impact of solar radiation. The first one, solar radiation provides the energy necessary for various natural processes, including photosynthesis in plants, which form the basis of the food chain. Solar radiation hits the Earth's surface unevenly, creating temperature gradients that drive atmospheric circulation, wind patterns, and the formation of the weather system. Solar radiation warms the surface during the day and cools it at night. Solar radiation provides the energy needed for evaporation, which is a crucial step in the water cycle. The variation, intensity, and duration of solar radiation influence the timing of plant growth, animal migration, and other seasonal biological and ecological processes. It is essential for photosynthesis in plants, enabling them to produce carbohydrate and oxygen. Solar radiation also influences the behavior, growth, and reproduction of animals. Let's go on the negative effect of the solar radiation on the Earth. Excessive exposure to ultraviolet radiation from the sun can lead to sunburns, skin cancer, and other health risks for humans and animals. Intense solar radiation can contribute to heat waves and health-related illness, particularly in urban areas with high heat absorption. Solar radiation can contribute to the formation of ground-level ozone and smog, leading to air pollution and negative impact on human health and ecosystem. Thank you.
Hello, I'm Meiman Karist from Stable Group 3 in Group 4 Agriculture, Economics and Agribusiness. Continuing for a presentation on application of solar radiations. The first application is solar power generation. Solar radiation is the primary resources for generating electricity. As you know, we use a solar panel to generate solar electricity. Solar heating and cooling. Solar radiation is also used for heating and cooling applications through solar thermal system. The systems collect and convert the solar energy into heat, which can be used for space heating, water heating, and air conditioning in buildings. In areas which are mostly affected by low temperature or coldness, they should use those solar instruments to fight against those coldness. The third one is solar powered transportation. As you see on the pictures, there are cars that parked at solar powered station. There's a car use solar energy as a source of electricity or as its power. Solar powered vehicles including solar cars, solar boats, solar powered drones use solar panel to generate electricity for propulsion. Solar charging stations can be used to charge electric vehicle using solar energy. Here are some challenges of solar radiations. The first one is cloud cover, atmospheric pressure, atmospheric pollution, and seasonal variation can reduce availability of direct sunlight, affecting the reliability and consistency of solar energy generation. You know that condition like a cloud cover may limit the intensity or the amount of solar radiation that an area can reach. Also, atmospheric pollution, such as industrial emission gases, may hinder absorption of solar radiation on the earth, and also seasonal variation can reduce or increase amount of sunlight available for specific region. Other challenge is storing excess energy generated during peak sunlight hour for use during a period of low or no sunlight is a significant challenge. The cost of solar panel inverters installation and maintenance can be barrier to widespread adoption, particularly in developing regions with limited financial resources. You know that to buy a solar panel require a lot of money. That's why here we say that it is expensive, or it may limit use of solar energy radiation, or as we have limited financial resources. Other challenge is integrating solar energy into existing power grid. This can challenging due to technical and infrastructure constraints. Also, while using solar energy is considered environmentally friendly, but its manufacturing process of solar panel and other components have environmental impact. Some regions receive more sunlight than others. limiting the solar energy potential in certain areas. Remote or off-grid location may face additional challenges in addressing and utilizing solar energy due to logistical and infrastructure limitations. In conclusion, solar radiation has significant impact on Earth, serving as the primary energy source for various natural processes and human activities. It drives climate patterns, regulates temperature, and enables photosynthesis. However, challenges include intermittent energy storage cost, land requirement, grid integration, environmental impact, and geographic limitation and technological achievement. Despite these challenges, ongoing advancement and supportive policies are driving the growth of solar energy. Overcoming those obstacles can lead to a sustainable and clean energy future, reducing greenhouse gas emissions and fostering the resilient energy infrastructure.
So, after the presentation of previous members and previous colleagues, here I came up with the solution to that in interactive assessment we have been given you before. So, what was the first question was asking, what do you think is the solar radiation? Here you have seen, as I've seen in the presentation of previous members, you have seen that solar radiation is electromagnetic energy transmitted by the sun and then they reach the earth. This is the meaning of solar radiations. Question 2 was asking, where do you think does solar radiation come from? We have seen that the main source and the only source of solar radiation, those solar radiations come from the earth, the sun. Then the sun is the primary source of solar radiations. The third question was asking what are the main components of radiations, solar radiation. The answer is that the main component of solar radiations are three, and then they are the ultraviolet, visible light, and the infrared radiation. Those are the three main components of solar radiation. The fourth question was asking to give at least three factors that may lead to the difference of solar radiations in different regions. Answer, we have seen altitude, seasonal variation, atmospheric pressure, and there are so many factors that may lead to difference in solar radiation among the different regions. The rest question, which is question 5, was asking how solar radiation may be useful. It was to discuss the usefulness of solar radiations. Solar radiation may be used in heating and cooling. We have seen it in the previous presentation. We have seen generating power and the solar-based transportation, solar-generated transportation. There are so many roles and how solar radiation is useful. There are many usefulness of the solar energy. So this is the answers for the interactive assessment we have been given above. This is a bibliography of the images. All those images you have seen in this presentation, they have a proof, they have where they came from. So those are the references for those images. So if you need to see the more, if you need to dive deep, you may use those links to see more about the images used there. So everything we have done has the reference, it has the where they came from. This is the references of this activity we have done. They have where they came from. So For more information, you can visit those websites and read those books, so to take more knowledge about this presentation and this topic of solar radiation. After this, if you need anything, if you're not satisfied with something, you may ask and we can answer every question you ask. Thank you. Then I hope we get along together. I hope nothing will have been said which is misunderstandable. So we would like to thank you because you have been with us till this time. We sincerely thank you for your kind attention. Hope to see you next.